Welcome. Come on in. Come to the front. Don't sit at the back. Just like scooch close. We promise we won't bite. I'm Greg. Thomas is down, and Jeremy is even further down. He made it just in time. Hey, Jeremy, how you doing?
How are we doing?
Great. We're just at the top. We're 1 minute in. Before we kick things off, in the chat, it's on the right-hand side. Ask questions. Let us know where you're coming from. Because yeah, we've got a bunch to share. And really, without further ado, let me kick it off to you guys. Thomas, Jeremy, take it away.
Let's do it. Hey, everybody. Thomas Martin here. I lead our sales engineering team at Switch. And we brought you all today in the same room to talk about our new products and how we want to install them. Ultimately, you folks are our representation, boots on the ground at some of our installations. And we want to make sure you guys are up to date on what we're doing on the product side. Jeremy, how's it going on your end?
Doing well. Thanks everyone for joining. We're looking forward to it. We have many trusted partners, installers, clients who have been with us for a long time, and we really wanted to get this out to everyone. We think it would be super valuable, as the industry is maturing, as is Switch. So we have some really great solutions that we want to share with you guys to get you up to speed.
Yeah, and in terms of agenda, I think we want to be conscious. You guys all have busy days, and so we want to try and wrap up our content in about 25-30 minutes. We'll move quick, so if we have your attention now, we'll get through the content, everything you need to know, and then we can spend the back half talking through examples and questions and that sort. So if you have a question, document it in the chat. We'll get to it along the way, and hopefully we can make a productive hour out of this. So appreciate you all joining.
Okay. Brief agenda. We're going to go over Cortex. We'll go over the products, most importantly, how to install it. We'll save room for questions after. We want to make the most use of everyone's time. So here we go, Thomas. Kick us off.
Let's jump into it. All right. So the $1 million question that you are all here is, what is Switch Cortex? That's what we want to understand today, and that's what Jeremy and I are going to hopefully shed some light on. When you hear Cortex or Switch Cortex, that refers to our entire EV charging platform. And so Cortex is our operating system, so to speak. And then within that, we have different applications or modules. Some of these you might be familiar with today, but we also just recently added 2 new key additions that we're going to spend some time today talking through, which is really going to change how we, one, sell the product, but also how we install the product. And so my goal today is to get right down to the nuts and bolts on how to install this and how to quote it. And so let's get right into it. So we have a couple of quick animations that kind of show where we're at. But as you know, working in buildings, getting internet connectivity to the underground parking garage is one of the more challenging features that we have to overcome. And so you might be familiar with our PoE-based wireless access point system today. And today we're going to talk about our new product, which is Switch Echo, that is going to change how we do this. And so the goal here is to eliminate the data cable, change out those wireless access points with the new Switch Echo devices that form a mesh on site so that we can effectively eliminate all data cable and make use of the power source already existing in the EV chargers. And so the marketing pitch that we've done investigation on is this is saving 70% of the cost to deliver communications to those EV chargers. And it is also going to add another step change in terms of reliability and network performance. And so the goal here, we're not really changing much to the user experience and how people interact with the stations, but we're making it a lot more cost effective to deliver the internet connection to those chargers. And as many of you know, this can add, the traditional path is a significant cost that we're trying to resolve. And so let's talk through examples. Let's get real specific here. So this is what we're looking at today. with our PoE-based wireless access point system. And before I go further, I want to address this system still works today, and it actually does a really good job in a lot of cases. So there may be cases where you still want to quote it, whether it's a unique installation or an existing installation. We can still use our existing comms gear, which is great. But for those new projects that look to utilize Switch Echo, we can delete all of that effectively. So you'll see I've crossed out my internet cables, my PoE switches, and my wireless access points. And we're going to replace those with our Switch Echo devices. And so there's two things that we need to pay attention to for how these devices behave. You have the connection from the Echo to the chargers, which is Wi-Fi based. Each one of these green highlighted sections represents each little Wi-Fi network that talks to the chargers. But then between the Echoes is a 900 megahertz low frequency signal that can penetrate concrete, and it can travel very far distances. And that's what allows us to create this wireless mesh in the garage and still deliver reliable communications. And so let's talk through all the different ways we can use this to be efficient with our installations. And so the slide I have pulled up here is virtually the spec that we wrote for how to use these devices. And so I want you to pay attention to two key things. First is our 1,000-foot line of sight spec, which is horizontal. So let's say we've got a really long, skinny, or a really large installation. We can travel 1,000 feet, in a lot of cases further, if the devices have line of sight. And that's a result of that lower frequency, longer penetration of the technology. But knowing that, we can also travel vertically through parking floors wirelessly. And the spec that we've wrote is we can go 2 floors vertically, not on an angle. And I want to call that out because the signal does not penetrate concrete well on an angle, but if it's orthogonal going directly up and down, we can do 2 levels. And so that's the spec we're trying to communicate to our installers. But I also want to highlight this area up here, which is our gateway. We're calling this the critical link. And because getting the signal from the gateway, which is receiving our cellular communication, down to that first Echo is the most important part of the installation. Because once we're in the basement, the devices have great performance and they're going to figure out the best way to distribute communications. But getting it down, whether it's through a ramp, we might be going through elevator cores, whatever it might be, that is very important. And so let's start there in terms of understanding how we want to build an installation. And so you can see here, we're giving it a 120 or 240 circuit, but we recognize that may not be the cheapest way to do it. Running a 120 circuit up the ramp just to power the gateway is more expensive in most cases than running our PoE approach that we're used to today. And so I want to highlight that you still have the option to do both, but we're showing this as our #1 solution because, we can't say it's cableless if we still have the cables running up to the gateway. So we like to lead with that. But you, as being our trusted installers, I want to highlight this still is an option. So if we need to run up a parking ramp, we could run a PoE system just to that first link, getting a data cable wired connection to that first Echo. And then from there, we distribute signal wirelessly. So this is possible. And I encourage you to bank on the Switch sales engineering team to help you navigate these specific installs. If you have drawings, it's going to help us map this out, and it'll help reinforce your design is going to be correct once we install everything. And so that being said, if we use a little bit of cat cable to, let's say, make things a little bit easier, we can also do that by running it a little bit further, or in some cases, running it down a level. We want to maximize what Switch Echo can do, but my point here is I want to highlight the impact of that first communication link being the most important and the thing we want to focus on to set ourselves up for success for the installation. And so let's move on to some other examples. In this case, you can see we have a clear line of sight coming down the parking ramp. So using the PoE-based system may not need to use it because the gateway up at the top and that first link can see each other. And so in the example that I'm about to run through, that's how we're able to get the cellular signal, convert it to the switch echo, and get it down into the garage. And so let's talk our first example. So this one here, very basic, one floor of parking. You can see we have our gateway sending signal line of sight down to that first device. And then from there, we can spread it out to the highlighted area, which is where our EV chargers are going to be installed. It's important to note here, the Echo has the same performance as a wireless access point in terms of its radius to communicate signal to the chargers in that area. And so you might be familiar with our spec today. It's about 80 feet line of sight. And so this Echo is well within 80 feet of all 6 of these charging stations, and we're set up and ready to go. But what happens in a multi-level example? And this is where things get a little bit more complicated. And so in this case, we have 4 levels. Each highlighted area represents EV chargers. And you can see they're not necessarily consistent. They're skipping parking floors. They're spread out all throughout the garage. So how do we tackle this problem? Step 1 is going to be our critical link, which is getting signal down to that first Echo. Most important step. So if we can get down the ramp, line of sight, clear communication, from there we can work with that. On the right-hand side of our diagram here, I'm showing you a cross-section of what we're doing floor over floor, just so you can keep track of the path of communication. Because ultimately these devices are going to be setting up a mesh, and their software basically figures out what's the best way to get this message to the outside. Is it through device A, device B, or through a chain of devices to get it to the outside world? And so the arrows you'll see on the diagram here are going to show you how those devices would connect in this example. So from here, let's get signal to the EV chargers on P1. And so we're going to place an Echo right by them, 80 feet line of sight. We know from there that Echo can talk to each charging station. And you'll see we're talking horizontally in this case. So we've got that 1,000-foot line of sight to play with. From there, our next step is getting signal to P3, which is down 2 levels. And so what I chose to do here as the solution engineer in this example is to put my first device on P3. And so we're going to make use of that 2-floor spec that allows an Echo to communicate from P1 to P3. But I want you to pay attention to the fact that those 2 devices are placed exactly on top of each other on the floor plan. And that's because to make use of that 2-foot or 2 parking floor spec, they must be on top of each other. Otherwise, if they're mismatched, they're not going to connect, and we're going to have a problem. From there, we deliver signal to each charger on P3, 80-foot line of sight. And then how do we get signal to P4, chargers on the opposite end of the parking garage? So first, we got to bring the signal down. And so we're going to go vertically again through the floor to a device on P4. And then finally, we're going to beam it over to the other end of the parking garage and cover that 80-foot line of sight to each EV charger. So you might be wondering, are there other ways to do this? Absolutely. And that's going to come down to the unique requirements in each project. You might note, if you follow my mouse here, we could have shuffled over on P3 and then gone down. Absolutely. But this is where we need to work together as a team and just figure out what the most reliable as well as most efficient way to do it. And so requires a bit of planning at the desk, but the idea is this is saving us a lot of time and money on site. So we've talked about Echo. We're really excited to use it. Let's talk about switch control, which is something you're familiar with today.
Thomas, I would say before you jump into switch control, if everyone who's on the call were to take away one thing from Echo, it's we are blanketing the garage in Wi-Fi to the best possible way that we can, as easily as possible, as most cost effective as possible, reducing the amount of labor, just key tidbits to take away. Thomas is obviously going to just make his way through here, but I just really want to stress that because of what I'm hearing out there from current clients who we're communicating this to, but also working with installation partners such as yourself. Just key things and little nuggets of gold to take away throughout the presentation.
Appreciate that, Jeremy. And for those on the call, Jeremy's our expert in terms of customer conversations and dealing with these types of projects. So good insight. I know a lot of you are familiar with switch control today, but I did want to bring you some updates that we recently rolled out to switch control. And so many of you are familiar using this technology to share the available capacity within the building for the EV chargers, whether that be one panel, multiple panels, the goal here being we want to avoid over installing on the capacity side. And so one of the updates that I wanted to bring you is that switch control is now UL certified. I know some of you on the call, I know personally I've worked with to talk to electrical inspectors on how do we make sure that this system is safe? How do we prove that it's compliant? We can now use this UL certification to put that up against so that one, the building knows they've got a long-term solution, but two, it makes the installation and inspection aspect of the project a lot easier. So switch control falls under the UL 6073.01, which is automated electrical controls. This is similar to a lot of HVAC systems and load management systems for other applications. We fall under the same category, and we're not stopping here in terms of certification. We've already engaged a number of other bodies to further certify it, as some of the features we're going to be coming out with later this year require it. But in terms of today, this is something we definitely want to brag about. So using existing capacity, shifting it to consuming load when we have available capacity, we're all familiar with this. But I want to encourage you to continue to use switch control to best design the system at I call it the desk stage, which is the planning stage. This is where we've realized we're very competitive and we make our installations very future-proof because the building knows they're not necessarily limited to number of chargers. They're just limited by the raw power capacity they have available to them, which might fluctuate throughout the day. And so I encourage you to continue to use this. And I wanted to draw on one little nugget, which is in a three-phase system, we spread the amperage across three phases. And in a lot of cases, we're able to really optimize the power consumption. And so I've seen a number of designs that did not take into account it was three-phase. And then after the fact, we realized that and could actually bump up the number of allowable chargers in that group. So again, work with the sales engineering team here, Jeremy, myself, as well as your local reps. This is what we're here to do, is work with you to best design the projects. So switch control, and how does it work with switch echo that we just covered? So as you know, switch control does need internet communication when we are metering a specific panel, transformer, or asset. The good news is control and echo can share a same power source at the location of a panel, and we can wirelessly beam that signal back to the main communication hardware so that we don't need to run a data cable to that specific electrical panel. I know in a lot of cases for the larger installs, bringing a CAT cable to each panel can be cumbersome. And so with Echo, we can now forego that and just simply use the panel as a power source to get our signal out to the outside world. So we've talked Echo, we've talked control. I want to introduce a second product that Switch has released called Switch Nexus. And so the theme of the industry is reliability. And especially in underground parking garages, network connection is our cornerstone to reliability. But what happens when we lose internet connection? Switch Nexus is designed to take over communications and keep the system up and running in the event of an internet outage. It's a local device that's going to live on site that is basically going to act as the mission control in those short periods of time where we might lose internet connection, whether it be minutes, hours, or even a day. Switch Nexus is meant to achieve that next step in terms of reliability. And in order to do that, we need to have a small device capable on site to do that. So let's talk, what is this and where does it get installed? And so just to show you in a small diagram how this works, Echo and the chargers are going to be behaving as regular. And when the internet is online, the installation can talk to Switch. Nexus is basically monitoring as a listening device and just keeping tabs on what each device is doing, especially Switch control. Because part of that UL certification that I mentioned previously is being able to guard against worst case scenarios. And in our case, internet connectivity ranks very high. So Nexus is our one of our solutions to keep the building safe, as well as all of the assets safe in the case of an internet outage. So as you can see here, we've lost internet. Nexus steps in as the local controller, and it's going to manage EV charging as well as the load management offline. And it's meant to bridge the gap so that the service to the EV drivers goes uninterrupted.
I'll say, Thomas, before you move on there, another little, golden nugget moment. Many of the real estate groups that I speak with, while they love EV chargers, they definitely love making money more. And any time that the chargers are down is lost money for them. So this new product that we have, many of these groups are very excited about because it is just ensuring the optimal uptime at the highest level possible. So I would say when you start to look at these installations, whether that be indoor, outdoor, all applicable scenarios, really just putting the Nexus forward is just kind of making this a security blanket for all. And it's just something that the groups are really, really pumped about, and we're just really excited to offer.
Exactly. Like if you look at the spectrum of solutions on the market, there's either a offline solution, which could be a plug, or a connected solution, whereas Nexus is actually giving you the features of both offline and cloud connected all in one. And so we're really, really proud to announce that. Now, before I move on to some of our other new, Caesar, just going to comment on your question in the chat. Nexus is optional. So it's something you don't need, but we certainly can add it to every install. Now, the existing products we have today have gone through a bit of a naming shift. Switch OS, which is our dashboard, is now referred to as Switch Portal. And we have lots of new features, but to spare you the time, we're gonna breeze past this one. And if you do want a refresher on Switch Portal, reach out to us. We're happy to do a refresher because we do have some new features coming out on the regular. But I do want to draw some of the new features to the user experience, which is what we call Switch Charge. You're familiar with the web app, the mobile app, RFID card access control. We're now introducing credit card readers as a result of market demand. And so you can still use the app as usual, especially for a lot of users that are using our chargers every day. They're likely going to use the app. But for visitors and guests, they might want to use a credit card reader because they can tap their phone, they can tap their card. And this audience being the people installing it, what do we need to know on how to quote and install these credit card readers? And so the good news is it can be 120 or 240 volt powered, just like our other communications devices. The goal here being we don't want to have to bring yet another circuit to the location. You can piggyback off of one of the existing charger circuits, and you just fuse this tiny little branch. It's going to use the same communications as the chargers. So as long as you're in the vicinity of the chargers, it's going to connect to our communication hardware. And the good news is this can be used on any number of stations as well as any number of credit card readers. So let's talk through some examples. This can be mounted on a pedestal or by itself as what we call a kiosk. And so let's talk through how we would use this when quoting. We can have a small installation with a kiosk in the middle serving both sets of chargers, or we could have the credit card terminal mounted on each pedestal. Mounting on each pedestal is a little bit more expensive. You end up with more credit card readers, but the option is there. Depends what the customer wants. And I'll just highlight this reader is talking to our gateway just like the chargers would. For a larger install, you might want to place this centrally or even potentially on the way to the building, just like you would a parking payment kiosk. This is where, each site is going to be unique. And again, the sales engineering team here at Switch is happy to provide you our best practices. As well as for even larger installations, you might want to have multiple. I know there's a number of installations, especially in the higher headcount, that require all sorts of solutions. And in this case, multiple credit card readers allows you to access any charger in that bank on any reader. And so the analogy we like to draw on is think of it like parking. You want to have the kiosks in a number of convenient locations. And so moving on to our, I'll say, last but not least, is addressing the conversation of cable theft in the industry. If I'm sure all of our news feeds are EV charging oriented, and you can see that there are many products coming to market to try and deter cable theft as it's become a ongoing problem. And so we thought long and hard about this on what to do. And we have come out and released a solution that we're calling anti-theft surveillance and monitoring. And basically what this is going to do is monitor the EV chargers 24/7 full time, and it's going to record that footage. We have a number of settings we can enable that will be motion detection, flashing lights, things like that, an audio warning people in the area that this area is under surveillance, all to deter theft. Ultimately, if people are going to cut the cables, they're going to do it, whether we like it or not. But if we can keep track of when that's happening and who, as well as have good footage, this will start to help the property better enforce it and allocate whatever resources necessary to prevent it. And so what we're trying to do here is install the cameras in a location that can see all the EV chargers. You might need multiple cameras. They've got a 180-degree field of view. So if you put this at the top of the pedestal, it can see the entire bank, both directions. And it's PoE powered. So we have a number of ways we can power this. And very shortly, we're also going to qualify it to be 120 or 240 volt powered so that you could piggyback off of a charger circuit as well. And the way it's going to work with the customers is that they're going to request footage in the event of an incident related to the EV chargers only. So we're not selling this solution to provide video surveillance for the property. It's mainly theft and vandalism related to the EV chargers only. And I wanted to highlight that just to make sure that people don't set the expectation that we're now physically monitoring all assets on the property. So when quoting, we need to think about the field of view and where to put the camera to, or the cameras plural, to best cover all of the EV chargers on site. And so in this case, we're close to a building. We can put it on the side, clear view. We're connecting to the gateway that we have connected to the chargers. We also can mount this on top of a pedestal, like in the photos we saw previously. Again, the 180 view, if you put the camera right in the middle, it's going to see two pedestals to the left, two to the right. We've got our situation covered. But that being said, if there's vegetation in the way, or there's a bend, or there's a pole, we could mount multiple cameras. And this is where it comes up to your expertise being the people on site. That being said, in the underground, we can make use of PoE because the cameras are enabled. So in this case, you can mount it on the ceiling, the wall to cover the chargers, as well as have multiple cameras from different angles for multiple areas of coverage. It's quite simple, point and shoot. As long as the camera's pointing in the direction and we're within a, call it a 50-foot radius, we're going to have great 4K resolution of what's happening at that site. So Jeremy, we're getting close to time here. We said we'd be about 30 minutes. And I just wanted to close off with a couple comments on hardware. Just some achievements we reached last year is you might saw in the news, we're now OCPP 2.01 certified. And again, that just comes back to our mission to developing our product to the highest standard of the industry, which is this certification. And so that leads us to be able to work with all the different hardware models, level 1, level 2, DC fast, to a very high reliability. Just wanted to highlight that. And our role here in the hardware conversation is to provide what we believe is the most reliable recommendation that has all the features to meet the need, whether it be certifications, to meet incentive programs or utility programs, state or provincial programs. We're really a recommending body, and we're going to put our best foot forward in terms of what we think is most reliable. And so please engage our sales engineering team and sales team to help with those recommendations, and we'll hopefully make that hardware procurement job a lot easier. And so with that, let's jump into the discussion and make this conversational.
Nice. Thomas, we have a question from Sam. Sam's asking, how long will Nexus operate the chargers without internet? Is there a limit?
So right now, there is no limit in terms of time, but I want to clarify that this is not designed to be an offline charging solution. So let's say internet goes out for a week. Let's say, lightning hits the telecom pole nearby. Nexus is going to be able to operate all of the chargers in the building, but it is not designed to sell as a strictly offline solution, because the expectation is that at some point in the future, Nexus will get established to the internet, and it's going to upload all of that information of what happened offline to the cloud. And that way the property can see it online. So Sam, to your point, it can operate indefinitely, but it's designed to fill the gap, so to speak. So hope that helps.
Nice. Lee came in with 4 or 5 questions bundled into one. Would you like me to read it to you?
Yeah, go for it, Jeremy.
What are the specifications of the Echo or the Nexus unit?
So Echo can be 120 or 240 volt powered, just like our outdoor communication gear. And so the idea there being, if fused and protected correctly, it will operate off of one of the circuits for the charging stations. Nice. And then with Nexus, it's going to fit inside the gateway. So you're not going to have to design anything special to accommodate Nexus. It's just literally going to plug into our gateway and it's going to be online. So no need to quote anything specific in terms of installation for Nexus.
What technical assertions is Switch providing to inspection authorities for one or multiple Echo units that take power from an EVSC circuit that require continuous 80% circuit capacity?
Yeah, good question. And this kind of ties into the question above that, which is how much power do they take? So Echoes are drawing about 10 watts of power. So it's virtually a rounding error when we're talking 7.6 kilowatts. And so from what I've seen previously is that if you're fusing the Echo to match the very low power requirement, inspectors are okay with that because you're within 1% of that 80 range anyways. If these devices were drawing, hundreds of watts and you're getting into 81% of the rating, that's where things can become problems. But since these are drawing such a low power draw, as long as it's fused to match that low power draw, from what I've seen, the inspectors are more than happy with it.
Nice. And lastly, is there a limit of Echoes installed per EVSC circuit?
There is not. I've never been asked that question. My only thinking would be if you add a bunch of them, I could see an electrical inspector making a case for you're overloading a circuit. So I would maybe take that on a case by case, but again, given they're only drawing, 10 watts each, you're going to be well within the limits.
Nice. Lee, great questions.
And there's another one there is, does switch limit power to EVSEs account for the additional power need for these units? If it ever did become an issue, we always could derate the unit by 1 or 2 amps to account for all that additional load. So I would say keep that in your back pocket in case you run into a scenario where an inspector is giving you a hard time on adding multiple devices to that circuit.
Caesar asked one earlier that I missed. Is LPR too much to ask for features?
License plate recognition is what I assume there. It is something we're working on. So I will say stay tuned. But as a part of this camera offering, we're looking to roll out a number of other features that relate to, call it non-charging vehicles, whether that be ICE vehicles or people plugging in but not charging, because we're going to want to enforce that. To Jeremy's point, a lot of properties, especially in the commercial space, view these chargers as an asset, and they want to make sure they're maximizing revenue. And so being able to detect, is someone just plugged in and using the parking space versus actively engaged in a transaction? It's something we've taken into account, and we're going to be using the cameras in the future to solve for that.
Martin jumped in there. Plans for multi-level energy management via control?
Monitor total building usage. Yes. So Martin, that's something we can do today. So what you would need is to have our CT clamps at those multiple levels, and then we could just basically design it as a tree in our system so that we know what the global limit is in real time as it fluctuates in the building, as well as what each individual panel is doing.
Nice. Lee jumped back in there. 10 watts for Echo. Got it. Sorry if I missed the answer. How much does the Nexus take for power?
Off the top of my head, I don't have the answer, but it's not more than 10 watts. It's less than 10 watts. And the reason I know that is because we're using the same power supply. And so it's got the same fuse. So 10 watts or less.
Great. And Lee, we're working on spec sheets for everything. So once those are generated, we'll circulate those so you have them.
You'll see those come around shortly. I appreciate you asking the hard details. And maybe a question for the audience, if anyone wants to chime in the chat. Was the spec we were using for Echo, was that clear enough for you folks? I want to make sure you feel like you've got a good understanding of how to design an ecosystem. I'm just going to quickly scroll over this diagram that shows us our spec, just in case.
And Caesar, the company processing the credit cards is Stripe.
But the credit card reader specifically, we've got a NIAX option as well as a PAYDER option. So we've got two companies going. Some features are on one model versus the other, and depending on the project, we'll pick one or the other.
David's in here. How do multiple Echo mesh units affect latency from a driver perspective when authenticating a charging session? Good question.
Yeah, latency is definitely something we've spent a lot of time looking into. Based on our experience, if you've got a long line of Echoes, let's say you've got 10 in a row, it's only really going to add, 5 to half a second of latency. So it's not like you're going to be starting a charge and waiting. I want to benchmark that we're not using LoRa. I know there are some other companies in the space using LoRa, and latency is a problem. That's specifically why we did not choose that technology. So I understand the question.
Lee's question about pretty straightforward Echo install, but I'm not sure about potentially 70% savings when we still have to run 120 volts or 240 power. What's your thoughts on that, Thomas?
Yeah, Lee, I'll answer that question by moving over to our top-down diagram. I will highlight in this diagram, you can use CAT cable if for whatever situation you're in, running power is more expensive. So you do have the option to use CAT cable. But in the case of placement, if I go to this diagram, you'll see I did not place the Echo directly above the charging station. If we want to make use and be most efficient with our conduit and wire, I would place this Echo basically on the wall here so that you know you have a circuit that you can tap off of, and it's all right there, clean and easy. Versus placing in the middle of the parking garage is, I'll say, case specific in the event where you actually have conduit and wiring running down the aisle. And so that's why I wanted to double down on the idea of mixing both data cable and Echoes for some of these more unique buildings. Corey, speaking of data speed, so no, we're not using LoRa. There are some issues that we found using LoRa, so that's not the technology. In terms of data speed, we're about 10 megabits, but that's going to change based on how the mesh is formed. If we're going really far, sometimes that data rate comes down to, about half, like 5 megabits. But in terms to support EV chargers and load management, it's more than enough bandwidth for us to operate. So the idea is we're not putting this in for people to be watching Netflix. It's mainly just to connect all the devices in the building and maintain them.
And Corey, another one about, is there a reason why the Echo is not capable to utilize commercial lighting at 277 VAC?
There's no specific reason. If you did want a 277 version of it, it's definitely within the cards. The assumption was that we would be using the charger circuits. Think of it from like a communication standpoint. We don't want to say hook up to the lighting circuit and then people say, oh, that's not going to work. So we're branding this as use the charger circuit, but you are welcome to use other power sources in the building. And if you do have specific cases where you need a 277 volt system, we can accommodate for that. You would just have to let us know. All I really need to do on the device side is just give you a different power supply in the device, and I know we can do that. So
great. Okay, this was fantastic. Wonderful questions, Thomas. Thanks for fielding them all. As I mentioned at the top of the chat, this is recorded, and we'll email this out to all of you probably tomorrow. We'll upload it so you have a video recording of it, so you can share it with any colleagues. You can use it as a reference. And really, if you have any questions, feel free to reach out to thomas.martin@switchenny.com, or Jeremy. Find him on LinkedIn. You can reply back to the email you get tomorrow if you don't already have a contact with your account manager. But ultimately, we're here to help make sure these new installations are delightful. So let us know how we can help. But otherwise, guys, thanks for joining and have a fantastic rest of the day.
Thanks, everyone.
Thanks, everybody.
Bye, guys.